Nice. We're live. All right. Thanks for tuning in on another episode of the Instant Quote Show. I'm here with Permit Zip Phil and Carter Permit Zip. We are currently working on our Twitter handles to try to figure out what the best marketing tactic is for that. Anyhow, thanks for tuning in today. We got a couple exciting guests with us, people that we've hung out with before, various places. I just heard somebody else jump in, and that is Jeff. I see him there. Hey, what's up, man? We'll bring you guys in a minute. You can hear us, but we can't hear you. Anyhow, another day of talking about the instant quote. I need to bring up my screen. So Carter, Phil, why don't you guys fill in a little bit of interesting time? Maybe y'all can try to call some of your other folks out to get on here. I'll put the comments up.
Yeah, just as we got to say who we are. For the first time you're listening to us, we're Permit Zip. We're an MEP, it's a mechanical, electrical, plumbing, engineering firm. We're based in Richmond, Virginia. We have a magical instant quote that you can use to get pricing for your MEP permit documents.
Mm-hmm.
And on our show, we have people on. We talk about their projects. We run a quote. We all guess how much the plans will cost. Price is right rules, obviously. I don't know why anyone would do it differently. I think that's the gold standard.
Yes.
We'd all agree.
Yes.
Closest without going over. And we will one day have a champion reigning supreme.
And we'll have a title belt for that.
Absolutely.
All right, so we get comments up. If you're here, Carter, Phil, can you put in the comments a link to join so that anybody... We've had a few people pick up some follows on Twitter out there from our videos lately, on-site videos. So if you're one of those folks and you want to talk about commercial real estate construction, this is a great episode because we got two people on the horn today. One is a master tradesman, and the other is another licensed professional engineer. So you virtually can ask anything to anybody on this call, and they'll be able to help you out. Just give me just 1 second, and we're going to talk about a couple of their projects, tips and tricks, things you can do to maybe save money. They know more than us about what's on the shelves, lead time issues. They're the direct source to the manufacturers for HVAC equipment. That's kind of who we'll be talking about today. And so throw in the comments. I got the comment section open. So make a comment on Twitter, LinkedIn. Yeah, you're in the background now. Jeff, we'll bring you up here in a minute. I am currently trying to figure out how to take my screen down because I don't know how the internet works.
We find our way.
Yeah, we do. There it is. All right, take that down real quick.
Muddle through.
Yeah. All right. Let's bring in Jeff first, and Bo, you'll be able to listen in and give him some private chat messages, and then we'll bring you in, and then we can all talk. What's up, brother?
What's happening?
Hey, not much. Just out here, doing our thing. How'd that concrete go today? Is that today?
Yeah, went good.
Heck
My
yeah.
little girls got to learn all about concrete pouring.
Oh, yeah. Did you ground it? Don't tell me.
I did.
Didn't. Nice.
Thanks for that heads up.
Yeah, I was talking to Jeff yesterday. He's like, I don't know if I can do the show today. I got to pour some concrete. I was like, make sure you put that UFA ground in. And if you're an electrician out there, you know that. Pro tip to anybody that ever has to pour concrete, make sure you connect a little, how much was that copper? Maybe $50 or something? I don't know. A little bit of copper.
Actually, my concrete guy had it on the truck. It didn't cost me anything.
Oh, really? Okay, good. Bond that rebar to a number 4 copper, depending on your jurisdiction. And otherwise, if you got to go to inspection and it's not bonded, they're going to make you rip up your concrete. I've heard it happen so many times. Anyway, that's a super nerdy thing talking to Jeff about yesterday. What you got today? What kind of job you want to talk about today, Jeff?
I guess we want to talk about that job that Bo wants you to look at.
Oh, okay. Well, let's go bring him in here too with us. Why not? There he is.
Hey, what's up, guys?
All right, I'll let you guys introduce yourselves. You're tuning in. You're in for a treat because there's 3 registered licensed professionals, 1 super insanely talented HVAC installer, and Phil, who knows how to trim hedges at the Federal Reserve. So,
Yep.
introduce
But
yourself.
wasn't allowed to without direct supervision. But I did do it.
Yeah.
Even Phil, I hadn't talked to you in a while.
Yeah, man. Good to see you.
You too. Sorry,
Yeah,
I
but
lunch down as we do this.
oh yeah. But what you got? Why don't you give us a quick intro and we'll talk about your project.
Bo Hamrick, Shelley Williams Company, sales engineer, master tradesman. I came out of the field and Jeff recruited me somehow and been around for probably 7 years with the Shelley Williams Company. VRF's kind of my thing, and obviously we deal in a lot of specialty HVAC situations, but the job I have here today is church retrofit in Northern Virginia. Essentially, they have a bunch of packaged equipment that is going out of commission pretty regularly. So, we want to incorporate a newer technology. Well, not newer technology, but for them, newer technology in the VRF and DOAS systems, and kind of demo this church and install it back up to today's standards, whether it be energy or zoning, comfortability, whatever that may be for them.
Yeah, so big CapEx upgrade. And how old is their system right now?
Judging by the initial site visit, I'm gonna guess around 25 years old.
All right, yeah.
It's really old. And another thing
R22?
Yeah, there's a R22 equipment there. They have an old boiler that I think was converted from oil to gas at one time, and they kind of built this church. It seems like around the HVAC equipment. So there's some air handlers up in the sanctuary that they can't get out without taking a Sawzall to them, and you can't install that size air handler back in. So I kind of came up with the smaller VRF air handlers and twinning them together and incorporating that with the existing ductwork, just to name one example. But you'll see that all throughout this building. And I think I sent you some pictures of it yesterday. But it's I've done this several times at churches in the area, and luckily the contractor came to me on this one, a totally separate contractor, just coincidentally. Kind of right up my alley, things that I do for Shelley Williams. But I'm excited about the project, and hopefully we can work with you guys. And obviously the contractor wants me to carry the mechanical and electrical engineering for this job as well.
Mm-hmm. Yeah, so a lot of questions on that. That this happens a lot. We have another similar project. If you're out there and you're an investor, developer, what we're talking about right now is a CapEx. Somebody's owned this equipment for a long time. And so this would be one of those buildings that if you were going to buy and invest in, this is a church, but this happens often where the equipment gets older and older and older and deferred maintenance happens. And eventually one day you just end up having to gut the whole thing. And now you have a church, as Bo's described it, that's fundamentally built around the old system. That's how much it was seemingly resisting the need to make that upgrade because it's expensive, especially if you have like a central boiler plant, old R22. So you're proposing VRF?
Yeah, that's correct. Basically taking out all of the old package units and trying to utilize the ductwork that's already there, that those systems support, and where we can at least. And there is ductwork throughout the whole building. And the idea really is to put in VRF, twin it where we need the ducted systems. And in the smaller classrooms, obviously, you use the consoles, and then the DOAS system that we're going to use for ventilation. Here we're going to try to use that ductwork in those areas with the DOAS, so that they're not essentially gutting the whole thing. We're trying to save them some money and incorporating what they already have.
DOAS, I was going to ask that question because that project I was telling you about, very similar. In terms of it being a major renovation for the HVAC, it's old dual chiller plant. One chiller in that building actually used to serve an adjacent building, and then existing serves the building in there. And they have a electrical boiler, by the way, which I don't know if I've ever seen. Do you guys sell those? Yeah, I mean, everything it's just weird. It's got to be like 400 amps or something dedicated feeder, 600 amps to that boiler.
Yeah, I've saw them, plenty of times, but not a
Yeah.
great idea. We'll sell them if you want them, but
Yeah, I guess there must have
it's
been a
not
need.
something I would advise.
Yeah, they have old generators, this whole thing, and they want to go VRF, and they got a price. And I asked, well, where's the DOAS? And they're like, we talking about. I'm like, all right, they're just, you got to be careful out there. If you're tuning in, if you're going VRF, it's a great option, but it cannot handle any ventilation load. Though I guess you can speak to that more.
Yeah, I mean, a lot of times people will, and it's partly VRF manufacturer's fault. They said, yeah, well, we have an outlet or whatever that accepts dedicated outside air. Well,
Mhm.
that's not the greatest idea. Just given sensible capacity and things of that nature. Certain times a year it might be okay, but really we want to decouple those and kind of have the DOAS on a reset space temp and let it handle neutral air all through the year. That'll actually
Yeah.
lighten the load of the DOAS, and the DOAS is there for just comfort.
For the non-nerds tuning in, the word DOAS is dedicated outdoor air system, and it's an expensive piece of equipment. And it's expensive because it can do miraculous things with air. It can wrench out the moisture from the outside air, which is required by code to be brought into your space. The big beauty of VRF is it's very modular. You can get a high level of zoning. You can do a lot with it. It can do heating and cooling at the same time. All types of fun, great things. But what it can't do is handle moisture in the air, and that's why you need DOAS, because you have to, by law, by code, bring in fresh air. Now, there's tricks. You can get around any ventilation requirements with what's called natural ventilation. We won't dive too much into that. That's a way to reduce the ventilation load, but ultimately, most projects at that size are going to have some required fresh air, and that's where, if you're going VRF, you need DOAS. So the trick is sneaking the DOAS in through the space and slithering the ductwork, because that's what's beautiful about VRF. It's small pipes, easier to get, your load. So that'll be a fun one. And you were proposing reusing some existing ductwork from the previous fan coils or something? Is that what you said?
Well, the larger split systems, and I don't know exactly how many there are. I'm going to guess probably 4 existing split systems that are fairly large, and they have air handlers in the attic. So when we take out the air handlers, obviously we have the existing ductwork. So the CFM is probably higher than what our DOAS is. So the initial trunk line will probably have to be disposed of. But I'm thinking as we digress the size later on in that duct system, we could probably save portions of it. Just my idea for now. I mean, obviously it's going to take a lot of maybe a few site visits and peeking our heads up above the ceiling and maybe even some existing drawings from them, but you know how difficult that can be.
Yeah, that was going to be my very next question, because we actually have another church that this is an issue with right now because they don't have as-builts, and as-builts rarely are accurate if you do find them, and they're expensive to get created. And that's, we'll talk about on the Instant Quote show, is actually something we've been trying to noodle around with, like how we exclude getting as-built conditions. So on this project, we'd have to figure out a way to get them. Sometimes if it's a full renovation and it's empty, you can scan it. That's nice. But if the ceilings are up and everything, then how the heck do you get it? The record drawings, if they're 20 years old, I mean, I'll give it to people back then. They would actually used to install stuff the way it was drawn back then, but people used to know what the heck they were doing when they drew it. Also, but chances are there's been a lot of renovations, and then you can't really trust it. So then it's like, okay, physically somebody has to measure each thing and get the ductwork network drawn, and that's going to be a challenge for this one. We're gonna have to figure that out. There's ways to do it.
Yeah,
refitting them.
Sent me a general layout. It's not to scale, and I think you have that. It's there's not a whole lot going on there. That's about all that I know. Besides the initial mechanical engineer that did go out to the site and kind of gave them a summary of what their options are and what's going on, and they just passed that information along to me. The contractor did, and the contractor, after I had given them the budgetary number for the equipment, and he put his installation budget in there, we were ultimately the lower bidder somehow. And
nice.
Yeah, so they want to move forward, but there's a lot to do here, and obviously
duct-
the first step is with you guys in
Yep.
mechanical and electrical engineering.
It looks like we have. Oh yeah, we'll have Carter's here, electrical engineer. If you're listening in, go ahead and ask any nerdy question. You got a whole group of experts on mechanical, electrical, and plumbing on the phone right now. So hit us in the comments. Any questions? Bo and I were just talking about his project. It's a church, major capex. I'm looking at the pictures, Bo. It looks like there's easy access, relatively easy to the ductwork, at least in the attic, based on these pictures. Hopefully
That's above the sanctuary, I believe, is what you're looking at, and
Yeah.
you see how it's crammed in between those trusses there. There's really no getting it out or putting air handler of that size back in. So,
Yeah, Jeff, are you finished with your snacks? I gave you privacy to eat. Yeah, he's all right. Good. I'll bring you back on. He was doing his lunch, so I let him have his lunch in peace. All right. So, any Carter on the electrical side? Any thoughts? On this project?
Yeah, obviously we're going to need new circuits for those VRFs, and then any sort of DOAS. That's typically a pretty large load item there.
Yeah, I don't know. Are they expecting any sort of major? I don't think anything would change on the electrical load that much if it's a similar tonnage.
yeah, our initial thoughts from it's actually a mechanical and electrical contractor. They
cool.
do both. And judging by those circuits and in the pictures, they have the disconnects out there. So the disconnects they're actually more electrical load than we'll need for the VRF. So essentially just taking that disconnect, maybe sub-panel it, and then put 3 extra breakers in it for dumb them down to go to each VRF condenser. And looks like there's plenty of power out there. Obviously, in my experience doing this prior, never had a problem with replacing VRF or replacing the existing package units with VRF. Obviously, VRF is energy efficient and typically has a lower MOCP anyhow.
I'm just hitting. So probably some sort of distribution board might be added. I would guess something that can. I don't know what the electrical circuits look like. We tap somewhere ahead at the service, add a new service disconnect if we want to. Maybe a little distribution board that can handle a handful of 200 or 300 amp breakers, or 50 amp or 100 amp, whatever all this stuff is going to need. Chances are those panels may be old, and that's always the difficulty. It's always cheaper to spend a little bit of more money sometimes on the equipment than guessing if I can reconnect all these branch circuits. That's the name of the game with electrical. It's like, hey, put a new panel right here, and we can get it shipped, get it shown up on site. Yes, day one, that's more expensive, but I promise you it's not as expensive as a 6-month delay of headache of trying to like retrofit these new circuits in whatever distribution is in there. That's more, if I were to guess, sight unseen, that's what that design will look like. Go to the service, backfeed it, like you say. Like if it's a gas connection, if y'all ever mess with that, same thing. Just like backfeed the gas, tap at the meter type thing, and then you don't have to worry about what's downstream. That's the same problem with electrical, because you might as well see if they have utility bills, by the way. If you're listening right now and you ever do adaptive reuse and you're adding load on the electrical, you're going to need metering if you can't get the utility bills. And if you can get away with it, or if you're the kind of person listening saying, oh, I've never had to do that, just wait until the one time you do, because it's going to happen when you want your inspections done and your CO you thought you were going to get next week. And since you didn't do metering, you're now 30 days away from when that metering comes in, and then whatever lead time your engineer needs. I don't think this will apply for this project, though, because they probably have utility bills we're going to want to ask them for. 12 months of utility bills. That way we'll know what their demand is. That's the only code allowable way for the engineers to see what the existing demand on the electrical service is without having to measure and itemize every single piece of equipment in that church, which would, be $30,000 of engineer time and honestly give you worse results. So cool. Let's, how many square feet?
I knew you were going to ask me that at some point, and I don't know. If I had drawings, I'd tell you.
There's this sort of to scale thing. These doors might be 3 feet wide.
Oh, yeah, I guess you could do it like that.
Let's see. Carter Phil, maybe you guys can scale it out on a Bluebeam or something. Get us an estimate. I'll tag you in the email. While Phil scales it in Bluebeam, we'll get a square footage here soon. We're about to run a quote and run some bets. If you're tuning in for how much it might be, I would just looks like maybe like 20,000 square feet ish. I don't know. Let's see. Let me go to email. Jeff, now that you're on, have any thoughts? Introduce yourself.
My name is Jeff Conzero. We run Shelley Williams Company over here, HVAC rep. Been in business for almost 17 years, and I've done VRF for 20 some years. And only takeaway I have from what you guys have been talking about is I don't know if we've ever come across a job where VRF needs more power than what was existing, unless they're making a pretty substantial expansion or renovation, something of that nature. But I mean, I'd say 99% of the time, the electrical load is substantially less with VRF, which is what makes it so attractive. And it's a whole lot easier to wire a lot of times than traditional split systems are, just because you can wire all your indoor units on one circuit. These air handlers only draw an amp or two apiece. So it's kind of neat to me how you can have 10 air handlers on a 20 amp circuit, no problem, versus 10 air handlers on traditional splits that all have electric heaters on them. And obviously there's a whole lot more power involved. So I think most of those savings is due to the fact we don't have electric heat in any of this stuff. These things will heat down to 0 degrees if you size them right at full capacity. So eliminating that electric heater on your circuit's a big deal, but also eliminating the cost of running those electric heaters to your owner or your customer is a much bigger deal. So to me, that's why these things really shine and why they're becoming so popular.
Can I show the floor plan here or no?
Yeah,
sure. Okay, cool. I'll just show so people can see. I didn't want
Nobody
to show
steal my job.
Yeah, I'll just show the floor plan. Yeah, and if you do, I won't. And if you want a price on the instant quote, I will reject it. Let's see. Here we go.
You have that power.
Yeah, yeah. Let me
use it.
bring the screen
I'm looking
back.
at roughly 31,000 square feet. Does that sound right, Bo?
Yeah, I would imagine it'd be close to that. Judging by the capacities of the existing equipment, I'd say that's fair.
Yeah.
Did Kenny just accidentally leave?
He may have.
I think he was trying to share his screen and he just left.
He's been concentrating on his rapping career.
Yeah.
Yeah, I guess so. All right. Well, I'm going to share my screen. We'll look at this floor plan. And again, don't steal Bo's job. We will drop the hammer.
Oh man, what just happened? Did y'all stay on?
Yeah. We got rid of it.
Oh man, that scared me.
Finally got rid of you.
Chrome crashed. Oh man. Oh, what's happening? All right, so back to my screen. Sure.
We are at 67 tons of existing equipment right now.
67 tons? Wow. Okay, that's good to know. So I'm going to bring in the floor plan just so everybody can kind of see that. That's tuning in. And if you're tuning in, shoot a comment in Twitter or Facebook or LinkedIn. We got nerds on the call that can answer questions about your projects. It doesn't have to be about this one. I mean, if you got a project you're looking at, we got experts here that can help you out. But for now, we're looking at this floor plan of a church. And just to give you some context what we're looking at. So sanctuaries, right off the bat, high ventilation loads for these kind of things. If you're a church, go back to my parallel building, Bo, that I've been talking about. It's a similar, but they actually have a church in it, and it's an office building, and that's part of the thing. It's like they may not go with us because what we're proposing with our contractor is, I think, more expensive because we're putting in the DOAS. And I think somebody else is trying to sell them this idea that they can install a VRF system without ventilation or something. I don't know how they're going to make this work. So that's a problem. So if you're listening and you ever want to put a sanctuary anywhere, and if you have an office complex, just be careful. The ventilation load for sanctuaries is much higher per square foot. We'll put a tool out here soon for y'all to be able to use. But sorry, my wife's saying bye. Bye. Anyhow, so here it is. We've got a kitchen. Is there a commercial hood in there?
That I do not know. Again, I haven't been on site. I just kind of threw a number at it and it stuck to the wall. So
yeah. Here's another one that'll come up though, is in churches, they often try to get away with an exemption from the code, and every jurisdiction has a different interpretation of whether that's allowable. And in our situation, the code technically says if you're cooking in an assembly occupancy, which this is, then you always need a hood.
Yeah.
But it kind of is up a type 1 hood, and that's kind of up to the jurisdiction. My cat jumped in on my table. And so that one could come up, something to keep in mind, and you guys got the hookup for figuring out how to spec that. But when you add a hood, more than me, that introduces more load to the system. So ideally, we consult people to save money, just say, change their programming. If that's going to impact their budget, we just say, well, don't put anything with an open cooktop surface in then, unless the jurisdiction's fine, calling it a warming kitchen or whatever. That's how you can get away from that. Just don't cook. Or use a convection oven with a recirculation, a listed recirc hood on it. That would be a good solution too. So
Or if you're in a church, you just say it's against my religion.
Yeah, exactly. To have hoods.
Yeah.
Yeah, I can't do that. It's not in my religion to have hoods in my buildings. I wish I could do something about that. That's actually, I'll start consulting that advice.
Yeah.
Any other let's see, sanctuaries, like I said, have high ventilation load. What's your email say on that? What were you proposing? Probably a dedicated constant volume something.
Well, given the fact that a packaged DOAS will not work, given the architectural state of the build, that sanctuary, so we can't get ductwork from outside to inside without opening up the roof. I'm proposing 1 or 2 smaller ERVs that we will use and just go into, like the eave of the roof or something like that, and just start drawing air and exhausting air.
Yep.
And not only that, it'll fit up in between those trusses, just like the air handlers that I'm proposing.
Yeah, I see 400 CFM ERV. And another trick of the trade, Josh Kreider, shout out to him from Howell's Heating and Air, taught us this, is the exemption in the code that allows for a registered design professional to perform indoor air quality calculations, an AKA bipolar ionizer. So if that 400 is not enough, then chances are by using a bipolar ionizer on the supply, we could get the ventilation demand lower.
Yeah,
Dude, how much are those things?
They're pretty inexpensive. A lot cheaper than DOAS systems. My problem is that after a year you have to change the tubes or the needle points or whatever, and people just don't do it. So then you wind up with a building that is just not getting what it needs as far as ventilation. And a sanctuary is a terrible place that you have elderly in there. As the building starts loading up, you need to have proper air exchanges, and that's my opinion, really. But I've seen it happen numerous times on jobs that I've done.
And just talk to us briefly on the kind of load in that space and what's difficult about dealing with it in a sanctuary type space.
I mean, 90% of the time it's not being occupied at all. And then all of a sudden on church on Sunday morning, you have the doors wide open and 300 people rush in there, and all of a sudden now you have the most extreme load, and you're going to design temps. Now that comes with humidity issues, and obviously in the middle of summer, it's really hot, so you're getting all that influx of air as well, and then really cold in the winter. So it's a really difficult thing to kind of maintain, and we've kind of learned our lesson that setting these things up on a schedule is very important whenever it comes to the sanctuary, so that you can have the system start to ramp up an hour or two before that service starts, and then it can start falling off afterwards. But don't try to do it as soon as the service starts. It'll never catch up. I mean, by the time that it's over.
Yeah, and I mean, one of the challenges is that churches rarely have money to buy the kind of equipment necessary for that kind of load, and then it's just difficult. And then you find what I see is people just throwing as many 4-ton standard split systems in there as possible, and it's just the worst thing you could possibly do. And then Jeff comes in and puts a DCA in there to fix it. Jeff, walk us through that, like how that works and like your proposed solution to fix.
Well, it's the ever so common problem, just like Bo was talking about, of oversizing equipment for peak load on Sunday service. And then what does that machine do for the other 6 days of the week when there's nobody in there? And the answer is it doesn't ever run because there's no load. So you start building up humidity in the space. It'll keep the temperature maintain no problem. But when you're not actively cooling and you have no read in the space, you're never dehumidifying. So now you start having mold growing in corners and things like that. And then at that point, after someone's already messed that all up, your only real solution is dehumidification with either a large piggyback system off of maybe, say, your rooftops, or smaller, like Santa Fe style dehumidifier scattered around the church. But it remains the same, and this is why VRF is dangerous at part load, or any equipment is dangerous at part load, because it never really runs. The coils don't get really cold, and you don't dehumidify. So then once they already cheap out and put oversized equipment with no humidity control in the equipment, let's just say a 20-ton rooftop serving a sanctuary, the only solution now is to put supplemental dehumidification in, unless you want to rip everything out and start over, which of course the church doesn't want to do.
Yeah.
So it really limits you in terms of how are we actually going to control the space, and the only real way is to put dedicated dehumidification in.
Yep. Yeah. This it's a very dangerous place to be, in that where somebody wants to do something that is expensive to do mechanically. They don't have the money for it, and then they ask for favors, and then the road to hell is paved with good intentions sets in, and we try to help somebody out, and then get to the budget, and then it's just not going to work. And that's the biggest challenge for me as an HVAC mechanical engineer, is getting yelled at because it's too expensive, and then making it not expensive, and then getting yelled at because it sucks.
Point out something else in sanctuaries that we run into all the time. A lot of times they have an organ there for $4 million that they need to humidify. So it has to maintain 55% humidity around that organ, or the tune's going to go out, or whatever happens with it. I'm not exactly in tune with all that, but
it'll destroy it though.
Yeah, so we're pumping humidity in around that organ. The rest of the sanctuary is getting some of that residual humidity into it, and it's running more problems.
Yeah. So you're humidifying it to keep the wood from drying up, or whatever, the parts and pieces, and then that basically introduces a latent load into the entire building, and then that building may not be able to deal with dehumidification. It's weird. It's expensive to be comfortable. I tell people. I'd never thought about HVAC in terms of its protecting assets. That's I don't know why, but I know I've talked to y'all about some similar stuff, like inventory and specific refrigeration requirements for labs and all this other stuff. I mean, we do a lot more like commercial, but an organ.
Museums.
Yeah, museums. Yeah. Man, I would never want to do a museum if they're going to not take my day one advice. I just walk away. It's like, you know what?
We're going right now. It's a museum, and then they have a bunch of artifacts in there, and they're using refrigeration equipment with a desiccant dehumidifier. And very, very expensive to do, and it's built inside of a cooler. So yeah, it's really interesting when you get into stuff like that. Very, very cool jobs, but very expensive too.
Yeah. All right, well, let's run it. Let's see what we get. Let me put this bad boy on here. We're going to go with 31,000 square feet, and just mechanical and electrical.
Yes.
Church. Place your bets. If you're using our website, you can always just get a quote online. That's what we're doing right now. Adaptive reuse. This is optional, but reuse. CapEx project. Replacement. DOAS plus VRF. That's kind of what we talked about. 31,000 square foot. Anyway, I put my name, Kenny for Bo, and Carter. Maybe you hook them up with a coupon code while we're doing it. We can show everybody how that works. Info@PermitZip. So if you're tuning in, what we do is talk about the HVAC or your project, whatever challenges they are in commercial real estate and engineering and architecture and construction. And that way you can learn something from it. But then we just go ahead and run our quote to see how much the engineering cost would be. And we'll call this the Bo Church. I don't want to dox your project. All right. And we'll do the first calculation. Before I do, you can put in your comments how much you would be. Phil, Carter, Bo, Jeff.
I have mine written down right here. I'm going to show you after you print it. If I go too high, then you're going
to... this introduces a new rule because it's Price is Right rule. So I'll do a round robin, and I'll start, and then it'll go... The permits that people can go first, and then you guys will have to go one at a time. Joe Jeff. So I'll put mine in at. Oof. All right. Phil said 19,000. Mine should have one more zero. Jeff's 12. Well, hopefully you'll get that with half price.
But I'm used
Hopefully it doesn't show up at 12 and then I have to do it for 6, but I will, so that everybody here knows that we're not. This is not a ploy. All right. Without as-built, of course. Yeah, as-built is a completely different project. We'll have to talk about how to do that. Is it? Another question. Are they expecting this to be phased, or are they going to be completely unoccupied?
So they're completely unoccupied during the week as of right now.
That'll be fun.
Also, the top portion of that floor plan there,
Mm-hmm.
the horizontal section, that was not in the original budgeting estimate. They only wanted to do from the nursery down to the sanctuary, but then they found some extra money, or we came in less than what they had expected and wanted us to add that on. So I would imagine they would do it in probably 3 phases: sanctuary, middle section, and then the top offices.
Yeah. All right, Jeff's at 12. Carter's at 25K. If you're listening in, put in your guess. All right. Carter said 25L.
25 lakhs.
That's
25
pound.
lakh.
Yeah.
And Jet Bo is 18K. All right, let's see who wins. Drum roll. Man, I wish that sound effect happened when you actually calculated it.
Yeah, we got on that.
Yeah, I got to get used to which button is which.
We give people a soundboard if they don't like the price. It does that record scratch.
Ooh, I think that Carter is the winner. That is
Ooh,
as
wow.
close as it gets.
No, I'm the winner. You got to take 50% off that.
This is, did you do it with the 50% taken off? This
Yeah.
is before. Oh,
No, he did not.
you're lying.
No,
He's
I guessed 24 and I halved it.
All right, well, then we're going to call yours 24, but you still lose to Carter, who had 25K.
No, you said yourself this price is right. You can't go over. So I win.
But that's not over.
You went
25K.
over.
How
Oh,
is
you're
20
right. Yeah, no, you're right.
No,
Oh,
guys, if you're tuning
25L.
in, Jeff is a licensed professional engineer, so he's really good with numbers.
Okay, here's why I'm correct. Because 25 pounds is about 29,000 US dollars. So he's over.
Yeah, no, that makes sense.
It's
Yeah,
true, Carter. You really should just stick with one currency, man. That's
yeah.
Yep.
Stick to what you know.
Just
All right,
been over
so-
to Italy too long.
You know what sucks is, unfortunately, you guys are both guests, so you both get a discount code, so you'll be able to use another one for another project since you both attended. It sucks for us, but we'll give you one. But Carter, what's the code for that I can use right now just to show people how it works?
Promo 123.
Really?
All caps.
Prom 1, 2, 3.
Prom 1, 2, 3. All right, here we go. Add code. Added. Now we'll recalculate it and see how it works. There it is. Definitely not including as-built. 12,500 is your price. And let's see. You can view a sample contract right now. An email just got sent to me. But this is what happens: is that you get the actual terms and conditions included. You got a 31,000 square foot religious facility for plumbing and electrical. Mechanical and electrical. And here's kind of the breakdown of what happens under the hood of what we're assuming. We do assume there's no type 1 or hood or anything, but I don't think that'll be a huge deal, Jeff, anyway, because we don't really would show it. It would just be like a separate submittal for permitting if they needed it. But the design and layout of all that stuff is not included for type 1. That's why I asked that question for that church. Keep it in mind.
Yeah.
But y'all, and sure we can figure something out. Anyway, all of our exclusions, all the terms and conditions are here. So if you're tuning in and listening, that's kind of what the Instant Quote show is about. Jeff is the winner. And I'll switch back over here.
Bo's the real winner here. He sold the job.
Oh yeah, and he got a hookup to his client. You know what you should do is just tell him it's 25K, and then you guys can make 12K on the
I don't
contract.
Yeah.
You just want me to send you both versions, huh?
know. Yeah.
Here's let me show it one more time for folks turning in. This is the discount code applied. This is a new feature, so you can see the amount deducted, and you can go to permitzip.app and customize these quotes a lot more. And there's a lot more features coming down the pipe for people. And what I like to do is work out that HVAC calculator that I was talking to you about, Jeff. That would be cool because it's the same inputs basically. To get a like order of magnitude tonnage, these categories really align pretty closely to the check values on the ASHRAE table. So you can imagine a world where this could be producing, hey, here's how much the engineering would be also be about this many tons. Or we build it for y'all to put on your website so people can say, how many tons is what I need? They could punch it in, and then it would say roughly around this much, and then somehow tie it to your equipment as well. Be like, and we would recommend this kind of equipment for the job. Oh, by the way, PermitZip would do it for 25 grand. So that's kind of what we're building. Tool
Bo,
for
did you
people.
say they had 72 tons there?
67.
67. I was guessing
67 tons.
I was guessing 400 square foot a ton for high ceiling church. That would have put you at 76 tons. So really, it's right at 500 square foot a ton for what they have there now.
Yeah.
Wow, that's low. I mean, high. Let me show you what I usually use. So if I need to put this on Twitter for people. If y'all ever want to know tonnage, this is what we use at the schematic level. I'll share my pin. ASHRAE cooling check figures. Do you see this? There you go. Can you read that? Is that too small?
Yeah, I can see it.
All right. So what it is, if you're tuning in, we're talking about just how to figure out tonnages and stuff. This is right out of ASHRAE. I don't even know if I'm allowed to be streaming this. Sorry, ASHRAE. But it's what it is these categories: apartment, auditorium, schools, factories, hospitals, and it'll tell you the square foot per ton for those categories. That's what we do. And it's a range of low, average, and high, because the real tonnage is going to be a factor of your location, the climate, and how much you care about being comfortable ultimately. And the kind of equipment. And that's what really drives the square foot per ton down, is categories like a sanctuary make the equipment category more expensive, or a medical facility obviously has more expensive equipment in it, so that's a driver. So anyhow, the tonnage goes needing more and more because you have more and more ventilation. That ventilation is cost tonnage. What is it? The rule of thumb, Jeff, Bo, 200 CFM per ton roughly for like DOAS. Is that what you guys use?
Dehumidification.
Yeah. Yeah. So it would be kind of neat almost to have this kind of thing where you plugged in the square footage and we could understand how to trigger behind under the hood when a DOAS may be a factor. And then you could tell them, like, this is how much ventilation tonnage you would need dedicated to ventilation.
You could probably base that assumption off of the density of people in a given space.
Yep.
In terms of how heavy is your outside air load going to be, just as a
ballpark. It's like so for I think religious facility is a category, is it not? Let me see.
Yeah, it's up there.
Yeah, it's in there somewhere.
Yeah, at the top. Am I blind?
The second one.
Thank you. Yeah, so it also talks about lights and watts per square foot, I guess, for power density, occupant density, and then over here. So yeah, 400 is, if that's where they landed, that's on the low side. So whatever factors lead to low side, and budget is often one of them. Like, people just can't afford the 250 per ton. And if you're tuning in, when we say 250 tons per square foot, you take the square footage of your building and divide it by that number, and that's your estimated tonnage. So it's a 31,000 square foot church. And if we use the ASHRAE check figure at 400 square foot per ton, we get 77.5 tons, which is roughly what they have in place now. And this is where we ask them questions, right? Like, Bo, have you talked to them qualitatively? How comfortable is your church right now?
Yeah, I have not spoken to them yet directly. I'm just kind of going through the contractor at this point, and I'm not saying this is my job until I see it on paper, obviously. So, it's the first step in it. But
yeah,
I would imagine right now they're not very comfortable at all because half the stuff isn't working.
Well, because sometimes these are just numbers. I tell people, like, no mechanical engineer would admit it, but it's just a giant guess. That's all it is. We're just like guessing that what you told us about how you're going to use the space is accurate, that the building has a good envelope, that the weather will behave this way. It's just a really giant, sophisticated guess. And it just kind of requires a lot of those soft skills that you guys have. That's why I love working with y'all, is you guys kind of understand how to work with people and get that out of folks. But in this question, if it was me just alone, I'd be asking, is it comfortable now? Because if it is, then maybe that 400 number could work. Or a restaurant's the same thing. Is it comfortable right now? Because you only have 10 tons, and my calculation would make you buy 20. And if they say, oh, it's comfortable, and it's not the owner just saying that because they don't care, you got to ask the line cook, are you sweating your ass off? Then that's the key. Because if they're right, if they have any memory of what it was like and it was operating, it is 25-year-old equipment, so it's hard, maybe hard to know. But then they're saying, yeah, we're comfortable. Then we know 400, 500, maybe we're fine. But we also have a decoupled DOAS, which is helpful, or an ERV. So it's a tough one, man. That's
help out with the capacity as well. I mean, that's going to drop our overall tonnage of the VRF because we're already supplying neutral air to the space and dehumidifier. So
yeah, and those are tricks that this old table may not be taking in. The bipolar ionizer we talked about, that would drive us to higher square foot per tons and stuff. So you guys already know those tricks of how to do that. So I would say we're probably pretty close. We could run a load. Just
I think Bo is spot on there, though, with the fact that these numbers, I guarantee you, incorporate ventilation air into this capacity.
Yeah.
So if you pulled that piece out of the puzzle, you might be at 600 square foot a ton for your sensible only heating and cooling, because we have no outside air ventilation load on that space.
Yeah. So
especially in a church.
Explain that to us, the listeners, right now, in simple terms, Jeff. What you just talked about, the sensible side of things versus that latent side.
That'd be the latent side. So roughly, as a rule of thumb, you're going to be around 20 to 25% of your total airflow will be outside air if you're just running ASHRAE Calc 62 to see how much fresh air you need to bring into said church. The way we did that for many, many years was just to bring it into the split system or the rooftop, and it's just raw outside air. It's coming in. We're not treating it at all. And then you're assuming that the latent capacity of that evaporator coil can handle that load, which typically it cannot. But we, for years, just let it roll. And a lot of the stuff that ASHRAE's check figures are based off of is the old school way of thinking that we are handling ventilation load and interior load with the same piece of equipment. The proper way to do it is to treat the moisture or the latent load that's coming into this church with a dedicated outside air system that will cool that air down and remove the moisture and then reheat it back to neutral 70 degrees, like Bo mentioned. And now we don't have any latent capacity being blown into the church, which is the dangerous piece of the pie, because that's where we raise humidity and start growing mold and having other issues. So by decoupling those two things, you're winning several battles. You're wringing the moisture out before you bring it into the space. You're making it easier for your equipment that's in the space to run. And we can control that with a CO2 sensor or scheduling or something like that. So we're not bringing in all that wet air all the time. We're only bringing it in when that sanctuary is occupied.
Yeah.
So a lot of advantages of decoupling the outside air from a VRF system or even fan cools or whatever else you got in the space. But it's important for people to understand that if you're bringing that moisture in and you're not taking care of it actively, it's going to snowball into a problem.
Yep. You mentioned mold. Adhesives, if it's bad enough, we'll start to peel off the walls. We've seen that happen.
We did a Catholic church several years ago. They had gold paint or gold flakes all over the place. And when the humidity is not right, the gold starts to flake off and they start getting upset. And we went in and installed the humidifier to take care of that problem. So, it's not just being uncomfortable when you don't take care of things properly. It can destroy your building.
Yep.
What we haven't touched base about is vapor pressure in that space. So if your church for some reason is hanging out at 70 or 80% RH all the time and you're not ever dehumidifying it, what's happening is when the outside air dew point drops to a certain point, it's dry outside or it's a pretty cool spring day, you have a vapor pressure inside of, say, 80% RH air, and you have a vapor pressure associated with maybe 10% or 20% RH outside. And that pressure will actually force that moisture through your building, through your studs, through your insulation, through wherever it needs to go to try to go to that lower humidity that's outside. And so over time, especially after years of doing that, you can actually jeopardize the wooden structure or the steel structure that's holding this building up to the point where you could have rust on steel. You could start having rotten wood. It's something that people don't really think about, but by handling humidity correctly, you're actually extending the life of your building structure on top of all the other things we've already mentioned.
What if somebody was penny wise, pound foolish? They said they over-engineered it and they neglected to take our advice on how to remedy humidity problems. What are ways to deal with it day two? Like, what are solutions to dealing with humidity if you fucked up and just bought a bunch of oversized split systems or something?
Well, number one, our humidity, the vast majority of our humidity is coming from that outside air. So something simple like putting a CO2 sensor on a modulating damper for your outside air and doing domain control ventilation, only bringing in that outside air when there are people in the sanctuary, that would make a big help. Obviously, adding supplemental dehumidifiers, that will make a huge help. Or even going back and using a dedicated outside air machine for that quantity of fresh air, maybe putting a small DOAS unit next to your rooftop on the roof, treating that outside air before you stick it into the outside air connection on the rooftop. And now you've eliminated that piece of the problem, and you don't have to rip your rooftop out.
Yeah, so if you're tuning in and you own commercial real estate, you may know this. Every time you call your HVAC tech in the summer and you're complaining about it being uncomfortable, actually, Bo would know this more than me. Bo, what's the most common thing you can do to help give somebody capacity? You go look at a rooftop unit.
Shut down the outside air damper. not doing you any favors, but
yeah.
If you got to work, you got to work.
Yep.
I'd like to note one more thing. On like the small standalone dehumidifiers, the larger capacity ones, I'll say, they do have outdoor air provisions. So you could actually have a supply return and then a smaller outdoor air provision on that. Obviously, it's not going to give you climate control, but you are wringing out moisture a little bit, probably better than what your conventional HVAC coil is going to do.
Yeah.
Just because of the airflows and what we're accomplishing out of that smaller machine.
I'm glad you said that. I was crossing my fingers because I know that's true. It's the only thing you can do. You just got to give the coil less load, basically. And
exactly.
It's summertime, hot, humid in Virginia. Safest. And so that's why you'll probably have people say, "Oh, my building right now has 10 tons. It's just fine." It's like, it's just fine and not legal.
Exactly. I would say 95% of the time, or you could walk into some commercial building right now and they probably have a fixed speed or a fixed damper on the outdoor air hood, and someone has closed that down all the way. And or you go up into their attic space and see that there's a big duct with a roof cap on it that's coming down. It has a manual damper on there, and somebody has already shut it down. Pretty much, like I said, 95% of the time. And also, those buildings have problems. You're looking at office space, dental offices, and smaller doctors' offices are like that all the time. And what do you need more in those spaces? Ventilation. So it's all about the bottom dollar for some people. And I think Jeff and I have learned our lessons over the years. If that's what they're aiming at, then we just kind of tell them that's a job for someone else. We want to do it right.
Yeah, that Josh Crowder said something similar on a VRF. He just won't even install it if they're not able to buy the DOAS that it needs. He just walks away. It's just not worth doing. It's just nobody should do that. If you're listening in, don't do that. It's a terrible idea. It's just going to lead to lawsuits, basically. Somebody's going to be mad, and they'll be the same people that said, "I don't want it." Not only is it borderline illegal because you need the ventilation anyways, but then you try to dump the ventilation on there. It's just not going to work. And then vapor pressure issues, Jeff. I need to read more about that. That's an interesting point. So you're saying like basically the water squeezes over time through the building envelope like little air water termites and just destroys the building because of that pressure. So it's like a balloon of pressure. That's huge. I need to talk more about that with folks. So that's when we talk about. I say it can't be as comfortable as you can be as comfortable as you can afford often, but I do also warn people when I see high ventilation loads, don't do it. You're going to destroy your building. Why spend $5 million on this just to guarantee that it's going to be destroyed over a period of a couple of years from the moisture that you don't want to spend money to remedy? that's been helping. Fear tactics, I guess, scare people into buying the right equipment. If it's not the code, I wish the code would just say something about it, but then that may not be the best solution either. But it's nice when the code is obvious. It's like you have to have this. Electrical, Carter can speak to that, but the NEC is either do it or you don't. But with HVAC, it's tough. It's mostly energy code driven. But this comfort stuff and the moisture stuff, I don't know. Are you guys familiar? Maybe somebody listening in, do you know any specific places where the code requires humidity that's not a medical facility, like a humidity set point? I don't think so. Only thing I know for set points is the heating set point in an occupied space has to be 65 or something in Virginia, 70. But if you know of it, let me know, because that would be helpful. I always tell the team when consulting, if you can make the code the bad guy, it's the easiest. You can't argue with that. Otherwise, we need consulting skills and persuasion, which I know both of you are gifted at. So that's why you're so good at selling, good communicators. Anyhow,
I think they make recommendations as to humidity ranges, but I don't think they ever come out and set in stone any true code, associated.
Yeah. I'd be curious if it's there. And a part of me would like it there, but part of me wouldn't, because that's a hell of a requirement to maintain. It's very difficult to land at a humidity. I mean, you've seen all the sensors, Bo. You're a tech. You've been in the field 1,000 times. You know more than I could ever know. Is it, even with the right equipment, how difficult is it to keep the actual moisture level in the space?
I mean, it's extremely difficult in Virginia. Because we have such, kind of mid-range temperatures and humidity all at the same time. So being able to control that is very difficult, especially when you have places like schools, municipalities where doors are open and shut all the time. Mm-hmm. It's almost uncontrollable, but we do our best to throw at it just this, basically like this church, decoupling those DOAS systems, having them operate by themselves. And there are certain other tactics, and you have to make people aware of that and show them, or hopefully they have an existing building or the building that you're renovating that you can tell them this is why you're uncomfortable and this is what we're doing to change that.
Mm-hmm. It's a hell of an industry. We'll get a few more episodes out there in February, I feel like, because I hear there's another ASHRAE thing happening. Yeah. But any other final thoughts before we wrap up? I know you guys got to get back to slinging some HVAC. Any thoughts or recommendations, or how can people find you?
Shelly Williams Co. On Facebook, and I think I could put our email in there or a phone number if you'd like to speak with us or have a project that you need looked at. We'd be happy to intervene. But ShellyWilliamsCo.com, and I think, Jeff, what's the Facebook? I don't have Facebook.
So just on Shelly Williams.
Y'all need to get on Twitter.
Examples on there too.
Get on Twitter. That's all the folks out there on Twitter these days, especially developers and things like that. The retweet communities has been huge for us and meeting new people. That's mostly who's listening in right now.
Okay.
And we'll tag, I guess, put your information out there for them to check out. But just so everybody listening, these guys are great. If you don't need an actual engineering firm like ours, but you need just some great consulting and advice, Shelly Williams, Jeff, and Bo, both of them are extremely knowledgeable. Jeff's a registered licensed professional. Bo is a registered tradesman and tons of experience, great consultants. So if you have a challenge, I definitely, we love working with them. We had Hoffman on last week. We love them too, but I got a special place in my heart for Shelly Williams because they're just so good at what they do. In fact, Jeff's company saved our ass several times coming in and actually making the design the right way. So can't speak highly enough about them. Thanks for being on the show with us, guys. I appreciate it.
Thank you.
We'll see you next time.
All right. See you guys.
Thanks, y'all.
We'll go